Okay, yeah, now we are alive. Welcome everybody to this New Year's session. I thought I would do another session after doing a session in New Year's Eve out of the blue. I decided to do this one instead. I mean, on top. So those who didn't have the opportunity to attend the previous session can have the opportunity to join and ask any questions. Before we start, let's see. Can you hear me? Can anyone confirm that they can hear me from the audience? Audio is good. Thank you, David. Yeah, perfect. Thank you. Where is everyone tuning from? I'm in Brazil. I'm tuning from Brazil. So I would like to know, feel free to drop a comment on where you are tuning from today. I know the QF, the quantum formalism community is a global community. We have people from all over the world. So yeah, thank you. Okay, so maybe I give it 1 minute before we start. I'll start first with some slides about QF Academy, and then share some things about the upcoming courses, and then I will open up to Q&A. You can ask any questions, and we take it from there. So we have people joining from South Africa, Nepal. Wow, this is cool. Well, welcome. I know David from South Africa. You have joined us before. Good to see you again. Yeah, so let me just share the slides. I promise it will be very short. It won't be long. Yeah, let's see if it's sharing this. Let's see, slide share. Can everyone see the slides? Yeah. Can everyone see the slides? Yes, perfect. Yeah, perfect. So let's get started. So the first thing I want to share is briefly what QF Academy is. So QF Academy is an extension of the quantum formalism community that we started during the pandemic, but it is the next level evolution for it. So it is a specialized e-learning platform aimed at offering graduate level mathematics tailored to specific outcomes. In this case, we are focused on careers, meaning that unlike the quantum formalism community, where people can join and audit the free courses without necessarily having anything in mind, with QF Academy, we really want you to join QF Academy if you see that the courses that we are offering, make a difference to your career. So the bar is really different, from the QF Academy community. And having said that, unlike the other thing I would like to mention is that unlike most e-learning platforms, for example, Coursera or Deep Learning.ai, who have like zillions of courses, we are actually taking a different approach. We are not focused on amassing large catalog of courses. Instead, we want to select courses that are deeply specialized and mathematical driven, that make difference to your thing, your objectives. This is the difference. And each of the courses, because of the mathematical component of the courses will be delivered by PhD level mathematicians, the mathematical component. The reason for that is because to really learn mathematics the way, the high level that we want, mathematicians are better teaching these topics that are featured in the courses. So you learn how mathematicians view these things, and hopefully that will make you have a better mathematical learning experience, be closer to how mathematicians think, in order to try to use that in order to make a difference in something that you want, whether you are doing a research in a specific topic and there is a mathematical gap that you have. Learning with a mathematician is the best way that you could have in mastering whatever the mathematical topic that you want to master for your goals. The other thing I would like to briefly mention is that QF Academy, to join QF Academy, we require a minimal prerequisite, which is basically you have to have some sort of a university level exposure to mathematics. This could be like linear algebra or calculus, for instance. So QF Academy is not really for those who have never taken university level course before. So it's definitely not suitable for someone still in school or someone who had just access to high school level mathematics. The reason we do this is because at undergrad, say university level, whether you are doing engineering or other applied topics like computer science, you normally get exposed to to stuff like linear algebra, for example, but mostly from computational aspect. You learn how to multiply matrices and this type of stuff. But the emphasis is not on things like proofs or understanding the abstract mathematical structures underpinning these objects, like matrices. For example, you might know that square matrices, so n by n matrices, when you multiply them, they don't. The multiplication is not commutative. For instance, you can, for example, if you have two matrices A and B, A times B is not always the same as B times A. So what you didn't know is that this rich structure, by the way, you can also do addition with matrices. This rich structure in matrices, for example, they form rich mathematical structures. For example, they form a ring. You probably never heard of the word ring, but the fact that you know how to multiply matrices and you understand these things makes it easier for us to tell you that matrices, n by n matrices with addition and multiplication, they form a ring. Likewise, there are certain type of matrices that are invertible. You know that, but what you probably didn't know is there is a very rich structure around that. For example, the group structure. Okay, so by having this university level thing, this exposure, it makes it easier for you to take our courses, which will focus mostly on structural mathematics, mathematical structures, their properties, and also on proof writing. So That's one of the reasons that we require that you have to have come from some sort of a STEM background and have taken university level mathematics in order to be able to take our courses. This is not to mean like, obviously you can sign up even if you don't have that, but it's just you will struggle if you don't have university level mathematics. The last thing on the slides I would like to share is the key outcome for us from a mathematical point of view is to give you this mathematical mindset, after taking our courses, so that you can, easily have these two circles here. First, you will be able to use, to have a mathematical intuition that enables you to also use abstraction, do abstract constructions, and at the same time as well, equip you to be able to apply that knowledge. And the other thing also is the other way around. You will be able to start with abstraction and then build up an intuition around that abstraction and be able to use the knowledge in order to apply the mathematical knowledge that you gained into a specific thing. This could be like a project that you are working on, or you're writing a research paper. So this is the key thing, the essence of Quantum Formalism Academy. With that, I will stop sharing, and then I will go to the other thing that I want to share before I open up for the Q&A. Okay, so I must have disappeared now, so you are able to see this, the course catalog. So the first 3 courses are available right now to start auditing. The third course is in production right now, and it will be available in the next 2 weeks. We expect it to be available and ready to audit by the 22nd of this month, which is a crash course on group theory, topology, and manifolds, all with the objective, of getting people who are interested in machine learning and quantum computing. So this course is designed for those people, specifically, who never been exposed to group theory before, or maybe they were exposed, but they don't feel comfortable with a lot of the key notions that are necessary for machine learning and also quantum computing applications. And this is actually also happens to be before you take the Lee Groups course. This crash course will be also a prerequisite for those who don't feel comfortable with the basics of group theory and topology and manifolds that you need to take the Lee Groups course. The reason for this is because Lee Groups, they are not group. The group name is there. Is just it's algebraic, but they also have like a topological. They have geometrical structure. So they are manifolds as well as the algebraic structure of group that they have. So the essence of Lie groups is actually how to work out the interplay between these two things. And the other, I will come back to this course in a minute. The other set of courses that we have, the Lie groups thing, this will come out soon after the crash course one. So for those who already have the background, they don't need to take the crash course as a prerequisite. They can jump straight into the Lie groups with the applications. In our case, we are focused in machine learning and quantum computing type of applications. Other courses on the pipeline are a course on fully homomorphic encryption and post-quantum cryptography. There's also category theory and operator algebras. I can comment more on this in the Q&A session if any of you guys are interested in this. Just before I move on, can you still hear me? Because I just heard something on my mic. Yeah. Can you still hear me? I see someone say great. Is that a thumbs up? You can still hear me? Yes, okay, cool, thank you, thank you. Okay, so let's go to the topology thing. So the topology side of the crash course. So there will be like 4 sessions. The first session will be a basic introduction to topology. So you will learn the concepts, the key concepts like open and closed sets, continuous functions, compactness and connectedness, these type of key things that you really need in order to get into manifolds. And then the second session will focus, the second part will focus on foundations of smooth manifolds. You will learn about the structure of smooth manifolds, stuff like charts and atlases, you know, and some other things that you need. The third session will focus on tangent spaces and smooth maps, which is what you need. And the fourth session will focus on the application of these concepts into Lie groups. Okay, so this will be more or less like the first contact that you will have to why the stuff that you learn in the first 3 sessions are relevant in the context of Lie groups. So this is the manifolds section, the topology and the manifold section. The group theory side will have only 3 sessions. So the first session will obviously go through the fundamentals of group, what a group is, examples to give you intuition. You will also cover other things like subgroups, you know, homomorphisms and isomorphisms. And this session, the second session, will then cover important things like group actions, and you know, you will have a first intro to, you know, representations. An easy introduction to representations, because they will show up again in the Lie groups section. And the third session will be more on this on the thing, focus on stuff like matrix groups, because these are the type of Lie groups that will be of our interest in the course on Lie groups with applications. And on the Lie groups itself, this will be the syllabus when we get there. So it will introduce again, you know, the concept of matrix Lie groups. This is one of the reasons why you need to know what matrix groups are in here in this in the prerequisite. So it's very important. And then, you know, we will cover both complex and real matrix Lie groups, because the real ones normally show up in traditional classical machine learning, whereas the complex Lie groups, like say, for example, the unitary group and the special unitary group, will show up in quantum computing. And then you will also have exposure, obviously, to Lie algebras and the tangent spaces, and the representation theory for both the Lie groups and their corresponding Lie algebras as well. And the last few sessions then will be dedicated to the actual applications. How do they show up in quantum computing? How do they show up in machine learning? So this is really the essence of this QF Academy curriculum, for you to really be able to master Lie groups, and then be able to be, you know, use that, you know, to understand papers or write, you know, algorithms and this type of stuff that, you know, are of your interest, whether in quantum computing or machine learning. With that, I will stop sharing, and then I'll look at comments and any questions that you might have. Any questions? I'm sorry, I like the Zoom or Google Meet. With this platform, I cannot just pull you up on the thing. We would have to agree beforehand for me to be able to send you the invite and all this. So it's not easy to add you on stage if you wanted to be on stage. So I'm afraid you have to comment. Any questions or comments? If you can still hear me. Let's see. Am I missing any questions? Can you still hear me, by the way? Yeah. Anyone has any questions or anything about curriculum or about QF Academy that you would like to ask? One thing I want to also, while you type or while you think about what you might ask, one thing that we will be doing, we are working on how best to do this, is to have the possibility for people to request courses from us. But obviously that will come with certain conditions. For example, we will most likely definitely require that you already have maybe a group of colleagues or friends that you want to take the course with. So we're not just doing a course for you. So yeah, okay, so we have a question here from David. Let me pull it up. Will each session in the crash course be 1 week? Yes, that's the original. There will be some instances where we will stack up the lectures, especially things that are related. Instead of doing them, so they will be stacked up in 1 week. You might have two lectures. And one thing that I forgot to mention is you, apart from the courses being released and you audit it on your own and try to solve the problems, there will also be live sessions to cover each of the lectures with instructor. So it's a great opportunity for you to first try to do things by your own and then show up in the live sessions with the instructor. I hope that answered the question. Let me know if you have anything else. So there's someone, George, saying I can't get LinkedIn up to work on my phone. George, I would recommend maybe using. Oh, okay, so you are on YouTube. I can see the icon. Yeah, YouTube, LinkedIn. I from my last experience doing this live session, LinkedIn wasn't that smooth for the users. So for that reason, I definitely recommend maybe you can join with the thing on YouTube instead of LinkedIn. Yeah, so this is also another question. So around, this is the thing, we will, it will be more or less around that, but we might actually release the Lee groups thing as well for those who don't need the prerequisite, because we do have some people coming already from, don't need, like, for example, people coming from mathematics background, for instance, they don't need to review the prerequisite, the crash course stuff. So they will be able to start. But we definitely recommend those who don't feel comfortable with group theory and and the manifold side of things to really don't start the Lee groups until you cover that, because otherwise you'll struggle. You will not be able to take it. And the key, the approach that you should look at, you should take, this is not a sprint, it's more of a marathon. You need to have, organize yourself, your learning strategy has to be, obviously we will help you. That's one of the reasons we have like a one-to-one calls for anybody who signs up for the course. So we can, work out the best pathway for them. But it's definitely, don't take the Lee groups course until you feel comfortable with group theory and manifolds. Okay, so anything else? Feel free, you can comment. Another thing I worth mentioning is for those who complete the Lee Groups course, they will have whole sort of other support from us available to them. For example, career-oriented stuff as well. If they were looking for new career opportunities and these things, because by then, you have proven us that, you know your maths, in order to say work in machine learning or quantum computing. So this question has to do with a competition that I made. Let's see. Okay, I will go to this one. What are the conditions to? You mean to attend? Well, you have to just go to quantum formalism / courses, and and sign up. Go to the course page, and you will have the the link to sign up. I'm afraid this is not. It's not. These courses are not free as well. It's worth emphasizing on that. So it's pretty straightforward. Just go and sign up, and then we will follow up with you. And now I'll go to this other question. This has to do with the Boxing Day competition that I did. Yeah, yes, we did. And I've already started to reach out to people, especially the ones that we selected. Their jokes are like the top, but everyone else who satisfied the condition at the time I'll follow up with them. Yes. Any other? Just out of curiosity, out of the ones right now, what's your interest in, like, in terms of the applications of Lie groups, for example? Is it to do with quantum computing related stuff or classical machine learning? While we got that, so there's a question here. What do you need to know to understand manifolds? Well, you need to know exactly what I was sharing before. This thing here. What is it? This thing here. In fact, so you need to understand what topology is. Okay. In fact, I might have something I actually forgot to pull before, but just a moment. Because manifolds are special type of topological spaces, right? So, you need to understand. In fact, I will just take my time just to give you something, an overview. This is actually a very good question, because I want to give you, let's see, I'm going to take a bit of time. Let's see. Just a moment to share this. In the meantime, you can comment. Let's see. Feel free to comment. Yeah. Yeah. Let's see. Yeah. This thing here this will do. Though there's something else I could have added extra. Just a moment. Do this. I'm taking this opportunity for the question just to give you something to why. It also shows why you need topology as well. Okay. There's another one that I cannot find that I did before, to show how these things are layered, But this will do. Just give me a second. All right, so let me just upload this just to show you something to everyone. Okay, so can you see this picture? So basically, manifolds, as I was saying, are special type of topological spaces. So you add extra structure. So they are special type of topological spaces. And in our case, we are interested in specific type of manifolds, manifolds that are differentiables, differentiable manifolds. And in fact, this is where I forgot, inside differentiable manifolds, there is a special class of differentiable manifolds, smooth manifolds, manifolds in a nutshell, manifolds that you can do, differentiation infinite times. So these are C infinite type of manifolds, basically. These are the smooth manifold. This is what the type of manifolds that you need for the Lie groups thing. So naturally, to understand manifolds, you need to understand first what topological spaces are, and then after that you will understand what a topological manifold is, and then differentiable manifolds, and then finally you go into smooth manifolds. I hope that helps. So definitely it's important for you to take this thing, especially the concepts introduced in the thing, in the first session. Stuff like open sets, closed sets, and this type of stuff. Compactness, for example, because the type of Lie groups that show up mostly in applications are compact Lie groups, and compactness is a topological notion. So this is one of the reasons why you have to understand the topological side of things in order really to be able to extract the essence of Lie groups. Okay, so George is saying comfortable real Lie groups as much, not sure about complex. Yeah, this is one of the things that you will learn from the crash course. Okay, so there's someone saying, in respect to my question about your interest in Lie groups, there is someone saying quantum information and computing, quantum information science in general, which includes also computing. Any other person interested in machine learning, for example? Classical machine learning. Yeah. Quantum machine learning will also be featured here as well, in this stuff like, let's see. And one thing, let me just emphasize, the interesting thing about this course, let me go back here, in here. So item 8, case studies and recent research and future directions. This is a great opportunity that we see for people to actually relate to the mathematical things that they learn with actual recent things, like papers. We will be reviewing some papers. Like, let me actually, speaking about that, there's this paper, for example, let me just pull it up from the archive, since we have someone who said they're interested in quantum stuff. If I can find it. Let's see. Just give me a minute. I have to go again. I'm doing this because this is pertinent to the thing. To the discussion we are having here. Let's see. Okay, actually, just a moment. I will share this. There's another paper on classical stuff that I think it's very interesting as well. Let me look at the quantum. Yeah, this recent paper actually. Yeah, this one. I will just share. Don't worry, I know you are not seeing. Let me just stop here and go to share. Yeah, so let's start with the quantum. Since there's someone, yeah, I'm using the, instead of a PDF, I'm just using the HTML thing. So this paper is very interesting paper called Geometric Quantum Machine Learning with horizontal quantum gates, and it doesn't take that long to look at this to see, Lie groups are all over the place, you know, all these things, so the idea is that after you take our courses, you will be able to, basically follow this paper and possibly do a project around this. And who knows, maybe you could even try to find some errors or something that there might be in the paper on the mathematical thing, on the mathematical side. Who knows? So this is on the quantum computing, papers like this are some of the things that we will be analyzing here in the case studies, recent research and so on. But there's also on the classical side as well. Yes. For example, there's this very interesting paper. I think it came out recently. This is classical machine learning already. With this one, I have it open in PhD, like this thing, symmetry enhanced multi-agent reinforcement learning. This is also another thing that, you will be able to see the application of what you learned, in the thing, in the course. You will be equipped with the mathematics to be able to. Okay, you're not seeing. I'm layering this. This is the paper I'm sharing. It's called Symmetry Enhanced Multi-Agent Reinforcement Learning. So this has just been published like last week. So, my claim is after you go through the course, you understand the fundamentals of Lie groups, of group theory, you will be able to follow papers like this. And we will also ask people to come up with suggestions, ideally on papers that they would like to understand in order to do some implementation or maybe carry on their own research, but the mathematics was a barrier for them to understanding. Yeah. So here's a very good comment. This is exactly our outcome, the outcome that we want for this course, to be able to get you to the level of being right now in the current state of play in research. Okay, so this is one of the reasons that we motivated us to create a Quantum Formalism Academy, is really this thing that mathematics can actually, if you learn the maths, especially with these emerging stuff that require advanced mathematical concepts that are not normally accessible to people who have taken, maybe they did their computer science or engineering degree a couple of years ago. Even now in the computer science and engineering degrees, this type of mathematics don't show up there. They are more focused on discrete structures, in these curriculums, and this type of stuff is, say, for example, in computer science, but this is exactly one of the motivations for us to create Quantum Formalism Academy. And this also aligns with what I was saying before, which is, we will focus in creating, not zillions of courses, but courses that are tailored, to interesting developments in quantum computing, but also in AI as well, in order to make people be able to understand and hopefully do a contribution to these emerging fields. Okay, let's see if I miss any other comment or questions. Maybe I'll take, I don't know if any other comment or questions? Quantum formalism really is for those who are really ambitious. They want to be like the top. This is what we want for quantum formalism, is for us through our courses to help you achieve that. So we really want the people who are really ambitious to be there, to go there at the top. This is the thing. And naturally will like require effort, right? Because nothing comes easy. It requires discipline as well, consistency. This will be one of the key things that will make you succeed. Very often, people get excited. They want to, you want to skip. Just very impatient. Just I want success to happen. This doesn't happen. Really, it's not realistic. You really need to put on the hard work. In terms of, for example, having accessibility to these things, to the mathematics. We will do our best. Our programs are designed exactly to remove that barrier, but you still need to do the hard work as well, the consistency. To go through and work your way, in order to succeed. I will just this is one of the reasons as well we charge, because you can imagine if it's free, everyone else people will just join in, without without anything. We'll just join in, and without with the completion rate. This is one of the things we really want to focus. We want our courses to have decent completion rate, so people will complete the stuff, as opposed to having like starting and then just quitting. That's the thing. And this happens a lot when the courses are free. Well, they are free for the user, but not free for us, because our time and the cost that we invest in bringing the courses. There are costs associated with it, and if people are not taking it, then it's like there is no consideration for the investment that we did. This is one of the reasons that we have to charge for the courses, to make sure that people will take the courses if they see they make difference to their career. Okay. Let me share on that, actually, about this thing about free courses. I found this very interesting. This comment by Zach Wilson. He used to work at Airbnb, and now he created his own course on data engineering stuff. And this is very interesting. Just have a look. So the first time he created his bootcamp, there were like over 30,000 people signed up. And only 65 people completed all the assignments and homework. Okay. And then when he did a paid version, 275 people signed up, but 150 people completed. Yeah. So that means this is also our experience, my own experience, doing the abstract mathematics 101 bootcamp, where we started with like 200 people. And then the thing faded around in terms of consistency to maybe 10, 12 people. Okay. And obviously this is not it's not sustainable for us to do this. Other companies, there was someone who commented, for example, saying like, oh, but Google or IBM, they offer free courses. Well, those companies, they have platforms. They are offering their free courses so they can lure you, for you to use their stuff, right? In the case of IBM, they have the Qiskit thing, so they're offering their free courses, and the thing is, the free courses are being used as a channel for you to, use the IBM quantum platform or Qiskit. We don't have that, so naturally, offering free courses doesn't give us anything in return, basically. So there is another question: which branch of mathematics with quantum material science. Well, if you want anything to do with quantum information science, definitely you need, you need your thing, your functional analysis, for instance. You need to understand your Hilbert spaces, the operators, acting on a Hilbert space. So in your case, what you probably need to take is, let me go back. For example, you want the mathematical foundations for quantum computing, which will cover the mathematics that you need to do anything to do with the quantum stuff. And I must emphasize, at the moment, we are actually, because this is what mostly people deal with. We are, in this course, for example, the focus is on finite dimensional complex Hilbert spaces, but there's something else where we will do the infinite dimensional Hilbert spaces as well, for those who are more advanced. In the case of this course, for example, when we get to like operator algebras, for example, this is where you will have really the necessity to review these type of Hilbert spaces that normally don't show up in like introductory courses, in foundational stuff. Yeah. So photonics, anything to do with light, obviously quantum mechanics has led. This is actually an example for, I'm not a physicist, but I know as a matter of fact that the Hilbert spaces have to be infinite dimensional. Okay, so you have to deal with the thing. So Hilbert spaces is something that you cannot escape, basically. At least the standard, this is the standard framework of quantum mechanics. There are other approaches as well that have been created over the past few years, like taking a more of a categorical, like category theory type of approach, but still important to have the Hilbert space foundational stuff, so you are able to see, to transition from, the Hilbert space framework, formalism, as they call it, to a different type of formalism. Let's see if I missed any other questions. Any other comment? Or question? So this is a very important question. Maybe I should have mentioned this. Actually, there is an optional, after the course, our courses, there is an option for people to do projects. And this is optional, and it is a must, actually, for those who want like a career-oriented support from us, because, you need to showcase your knowledge and these things. So there will be for that, and for certification as well. Yeah, so if you want a certificate, you need to show us, that you have accumulated, the knowledge that you learn in the course, and you are able to do something. Show us something about it. So we would. It's more of doing that than doing like the standard academic, exam type of stuff, right? Not at least, people nowadays can maybe use ChatGPT and these things. And by the way, this is a thing as well. Please, I've seen that in my free course where people in the assignments, it's clear that they're using some sort of a ChatGPT thing. The way they were write, it's very like. Wordy type of things, in their, assignments, that's not, do not do that. The purpose for this course, for these courses, is for you to actually do the things, because otherwise, unless you find a way of embedding ChatGPT in your brain, there's no point. It defeats the point for you to learn, the maths and be able to yourself create something, so that's one of the things that we will be very thing with assignments to make sure that people are not using anything for the assignments. You can use AI. In fact, this is another thing as well. I would like you to look at our GPT called Advanced Mathematics GPT. Let me show you. Here's a link for it. I will drop it on the thing. So you can use that to help you, especially if you struggle with abstraction. You can use something like that, to help you learn or assimilate the concepts, but do not like use the GPT itself to try to do your homework, because it defeats the point. So it's this thing. For those of you who have ChatGPT, you can let's see. Let me share. And we already have like maybe I think 30,000 or 25,000 conversations already on it. Yeah. So this thing here, here's the link. I don't know if you can see the link. It's called Advanced Mathematics GPT. I will drop the link on the thing on the chat here. You can look at it. This will be like maybe a good assistant for you. You in case you are struggling with the formal definition. You can go there in a natural language and try to help you build your intuition. But by no means that you want to use this something like this to solve your homework. The homeworks are meant to be just for you to try to do them. Let me actually, what's the screenshot here? Just let me see if I can show you what sort of questions that you can ask with this. So just give you a preview. That's because I'm using a different browser tab. Just a moment. And it can be used. I'm not against you using tools like this for learning purposes, to assimilate concepts, but not for like doing the homework for yourself, to think, because that you have to do, because otherwise you will not. What is the point of joining, trying to learn, because your research has to be done by yourself, right? Not the GPT. So for those with the ChatGPT, you can use this. It's free. I think OpenAI. We don't want to charge for it, so we just release it there, and I think OpenAI now made it available to everyone. Yeah, it used to be, I think, it used to be like only for those who are who have the subscription premium thing, that have access to it. But I believe now everyone can do this, have access to this. Yeah. So you can see some of the questions that you can ask it. For example, what is a fiber bundle? What is group cohomology? What is a smooth manifold? Which is something that you will learn, and these things. So you will see, for example, what is a smooth manifold. You will see the formal. But if you struggle with the thing, maybe you can use something like this to try to enforce your understanding of the topic. But again, by no means that we want you to use this as a way to solve your assignments. Assignments are meant for you, especially the proof writing stuff, right? Because you need to be able to do that yourself. In order for someone to be able to hire you. Think about it. Why would someone hire you if you are using ChatGPT? They could also just use ChatGPT to do their thing instead of hiring you. Or as they call it, we are not there yet, where you have like agents that are able to do things, to do research and this type of stuff. Maybe we are heading there. It could be you guys who will create that. My own personal view is that for us to get to that point, we need to deploy much more sophisticated mathematical frameworks to do this. This thing of just calculus and linear algebra will not do for you. I mean, calculus was invented like, is it 400 or 500 years ago? This is one I was saying to someone like, people think machine learning is hard because, they think calculus is hard. Something that was invented in Newton's time, Yeah. So our mission in QF is actually to bring you, to modernize, the mathematical stack that, you traditionally are available, only accessible to people coming from mathematics or perhaps theoretical or mathematical physics. Any other question or comment if I'm still on? I'm not sure because with this platform, it's very hard to actually. Am I still on? Can someone confirm? Yes. Am I still on with you? I haven't disconnected. Let me check my network. Well, it shows I'm connected, but I don't see anything on the chat. Oh, yes. Okay. Yeah. So there's a bit of probably latency or something. Yeah. Maybe I can also mention something else that, let's see, scholarships, because that's another question that a lot of people have been asking us about. Oh, we want scholarships and these things. So I'll make a comment on that. We are working on it. Let's see. Let me just pull the thing about that. So we are all on the same page. Let me just. Okay, so let me go back here. Right, so I think I shared this like in my first live session when we talk about introduce QF Academy before we actually launched the platform, before things were ready. So yeah, so we are working in having scholarships. We don't have a timeline yet, so don't expect. It will probably be after all these courses, the league groups and the prerequisite and these things have already started. So I'm afraid because we have only limited time that we can deal with multiple things, and we are prioritizing on getting the content and also those who signed up first, to get them onboarded and get them started. Then we will switch to scholarships. Yeah, but recipients must have a compelling reason to why they should be awarded. Okay, and one of the things is like it's not just because they can't afford it. Not just because it's expensive and these things. No, but why do you want it? Does it make any difference to you? And also being from a developing country does not automatically qualify. It is one of the, it is something to take into consideration, but there must be also a stronger argument, a stronger case, for us to be able, because we have limited places. Okay, we cannot offer zillions of scholarships, so there are only limited places that we can offer. So, and these will be awarded to only people that we think, have, first of all, they have the baseline, the knowledge, the prerequisite, like university level mathematics, for example. That's one of the things. And they must be also interested in doing something with whatever course that they want to access. Okay. And most importantly, they do need to have time, to go through the program. Okay. Because we are not just interested in giving people access and then, oh yeah, I don't have time, my work, my whatever. Yeah. that's not an excuse for us. When we give you the opportunity, we do expect commitment. Because think about it, if you are given the opportunity, it means that someone else hasn't been given the opportunity, right? So it's like you are, occupying space that could be given to someone else. So it's not, it wouldn't be fair for the rest of the community, would it? So we really will be very rigorous with this, to make sure that people go through the program. They have time, so only apply for the scholarship when we release them if you do have time, to commit to it. Okay, and the other thing I wanted to say is that the scholarship will be we'll have like different type of scholarships, in particular in honor of mathematical figures and also some outstanding community members that have been helping us, being part of the community, helping others, and this type of stuff. Yeah, but we're still a couple of weeks away from actually having something more structured around this. Yeah, so there will be scholarship, but they will be limited. Not everyone, So my advice is, if you can pay, you join. I mean, our pricing are very accessible. If you go there, our courses, you can also take them through subscription. You don't have to buy them one-off. You can, sign up for the specialization plan, and you have access to all. I've seen introductory courses in quantum computing, costing $1,000, where people are learning trigonometry, this type of like basic stuff. And we are offering you, our pricing, the pricing point that we have, is like peanuts, especially if you are, based in the West, for example, or even, if you are a professional working anywhere in the world in this field, it's something that you would spend, in an evening, less than 1 hour in a bar or something that you would spend, So pricing wise, I think we are very accessible. So if you can pay, do that instead of waiting for the scholarship, because there's no guarantee that you will get them because it's a competitive process. So that's what I wanted to add on this thing of a scholarship, because people have been emailing me quite a number of times, asking about scholarships. Any other comments about scholarship or something? Okay, so I'm fine loud. I hope I'm not too loud. It's because I can hear the cars behind me. So, yeah. Yeah, so let me highlight this question. Thank you, George. Yeah, we are definitely cheaper than edX and, Coursera stuff, And these platforms are focused just in like, making you accumulate certificates that you can go and brag on LinkedIn. We are not interested in that. We are interested more in impact. Do you want to be at the top, and do our courses, the stuff that we offer, give you the opportunity to help you get there? This is what we want. We are not interested in just issuing a certificate. Oh, look, I completed this. And no one will hire, especially those who want to a career opportunity. No one will hire you just because you waived a certificate of Coursera or something on the thing. People will hire you because of the knowledge you accumulated. Okay, so that's the thing. Thank you, George. Any other comment? I've been asking any other comment in this thing because I don't want to disconnect. I wish I could stream for like 24 hours, in order to accommodate all the different time zones within the QF community. Any other thing, whether on the scholarship or something else that you might want to bring to me? There's something I want to share as well about, because someone asked the question about the Boxing Day competition. So we will have another event called Joke with Lee, where we'll actually ask the community to vote the best jokes, and then we'll have an event to award the top 3 jokes. How about that? There were some very cool jokes actually. And the people who have been shortlisted have already been emailed, to tell them that we shortlisted six jokes that we think are very interesting. In the contest of Lee, there were other people who didn't do any jokes in the contest of Lee. Okay, so there's another question. This to do more with the community stuff. When is the next bootcamp lecture? This is a good question. I think it's probably looking like it might have to be like at the end of the month, because of my availability in terms of coordination about producing the prerequisite, this crash course, and also the Lee stuff. I'm not the instructor for those courses, but I have to coordinate with the instructor, in this case, Brian and the others. Yeah. So I think January 31st will probably be the earliest that we can have resume our bootcamp. Yeah. By the way, for those, thanks for mentioning the bootcamp, because this is something also I can highlight here. For those who, I will be in my bootcamp, I will be covering Lee groups as well, but not in the context of application. It will be just, pure, just a mathematical thing. That's why we call the course Abstract Mathematics 101. And let me share just this with you. Formalism. So actually, we have related to this question that George about the bootcamp. We already have some people who were actually taking the bootcamp, but they also signed up for the Lee thing, so they will get to learn about Lee before the actual bootcamp. Yeah. Let's see. What do I want to share? Let's see. Yeah, anytime I'm looking for something, it's like it takes ages because I do have like too many things. Yeah, it's here. Yeah. Okay, so can you see this? So this is the Abstract Mathematics 101 bootcamp that I'm doing. You can go to our GitHub page. I will share that with you in a minute if you wanted to enroll on that. So at the moment, we are in the metric topology section. Ignore the date here because module 1 meant to end at the end of August, but because we are doing the bi-weekly sessions, and also I did, because of my availability, I did skip a few lectures. So it wasn't possible for us to stay on track. Yeah, but we are in the metric topology section. So people who are taking there, they should already know what topological spaces are, in particular compact topological spaces, the notion of compactness. And then we will cover topological manifolds. So we won't cover differentiable manifolds. We will just cover topological manifolds in this module of the free Abstract Mathematics 101 bootcamp. And then the smooth manifolds and the other more advanced mathematical stuff will be covered in the second module, which we don't know yet when. We don't have a date set for that. Let's see, I do have a question. Yeah, you can, by no means. Yeah, George, please. We can have a study session in a, yeah. And you have permission to join, as long as you join, because you are added there as a thing, as an instructor or assist to help the community. You are able to initiate the Google thing. Yeah. I will also follow up with you, George, about some the stuff that we've been talking about before, a few weeks ago. Any other questions? I think we just gone over the hour, so I'll give you like 1 minute. If there is no other question or comment, maybe we can end it here. And you can always reach out to me on LinkedIn, and subscribe to our Substack as well, so you get the latest updates. But definitely, I look forward to seeing you in the Tech in the Academy. As I said, our objective is really to help you master the advanced mathematical topics that you need to be successful, to be at the top. So I look forward to working with you to help him build your mathematical advantage, basically, myself and all the structures from our side, from the QF Academy. Okay, cool. So I don't see any questions. Another chance? Yes, no? Okay, well, we can end it here. So thank you, everyone, for your time, for your company, for the questions. And, I hope, you have a little bit better overview of QF Academy, what's coming next than the Boxing Day, the New Year's Eve session that I did 2 weeks ago. Yeah, and I'll see you next time. I will be doing more regular sessions, and there are some initiatives that we will also be announcing. We haven't announced it yet, so I cannot preemptively tell them. But yeah, it's really great to have you in the QF community, whether you are just in the community stuff or you are transitioning into the academy. It's great to have you, and thumbs up for seeing mathematics as being something very important for you in achieving your goals. Okay, so with that, from Brazil, have a very good evening. I cannot say on live that I'm going to have a caipirinha, but maybe I will. I don't know. So I'll see you next time. Thank you, everyone. Yeah.